All right, folks, let's keep it going here. Our last thing that we're going to cover is how to describe, compare and contrast multiple distributions. So what I have for us here is the number of goals scored by the 2016 men's U.S. soccer team in the same 20 games. Not in the same 20 games, but the same number, 20 games. The same number of data points. So this is, again, quantitative data, and we don't love this data because it's not random, which leads us to question if it could be biased. So if I love the U.S. women's team and I hate the U.S. men's team, maybe I picked the highest scores for them and the lowest scores for the men. So unless it's randomized, it's really uncertain if it's biased or not. So not random. Being not random brings potential bias, okay? So let's represent the quantitative data with a graphical representation. So which makes the most sense? Now I'm going to pick a dot plot just because the stem plot really doesn't make sense with this data. It looks like all of the men's data is in the 1 digits, no 2-digit numbers. So why would we use stems? And then histograms are fine, but again, I kind of reserve those for more when I have a lot of data points. So we only have 20. We can do that by hand. So since we are comparing these data sets, you should want it to be pretty similar. But I feel like I'm kind of breaking that because I feel like I'm spacing this out way more because I felt crunched before. But again, not the end of the world. Most likely, statisticians use technology because it's more accurate. Alrighty, let's get graphing here. Very relaxing activity. Three, one, 4, 0. And again, we don't want to mislead. We don't want to mislead our anyone looking at our graph. So make sure you are working on your spacing, even though I'm sure it's not going to be perfect unless you are an excellent spatial reasoning person. But we don't want to over-represent one particular data point. So make your dots similar. Okay. 0. Back at 1. Back at 0. Back at 6. Okay. So again, I'm going to count 20 just to make sure I've got 20. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. Always a good idea. We always want to title our graphs. So goals scored by U.S. men's. We want to give the year because that's definitely important context. Okay, so there is our dot plot. You could have certainly used a histogram, folks. If you're dying for a histogram, make one. Put this data in your calculator and generate it on your calculator. If you're doing it on your Chromebook and you can insert an image into a doc, that would be even cooler. I should have done that. But anyway, okay, moving on. I picked a dot plot. Maybe you did too. Let's try choice D, and then we're going to compare and contrast both of the distributions, okay? So this is the same thing. If the news was reporting that you can expect, keyword expect, more than 5 goals, do we agree or disagree? So in order to answer that question, we're going to see, well, what's the proportion of games where they score more than 5? That's only 2 of the 20 games in this sample. That's only a proportion of 0.1 or a percent of 10%. And so again, we're going to disagree. That's probably not likely, probably not something you want to say you can expect. But I want to point out that our answer was the same for the men's and the women's. And when we describe the data, you'll see that actually the two distributions are very different. And so it just goes to show that, one number or one statistic could be the same for two data sets, but until you're looking at the actual data sets, that can be very misleading. Okay. So let's do it. Let's compare and contrast the 2016 U.S. men and women's soccer team. Okay. So we're going to start with shape. So we are going to need all 4 of our check marks: shape, outliers, center, spread, socks. But we also want to be using comparative language. So sometimes I have students that say shape, they're both skewed right. Well, that would be actually true in this case, but try to do some comparative. Okay, so they're definitely both skewed right in that most of it is on the left and they're kind of being pulled up a little bit, but less so with the men's. So I'm going to say they're both skew right, but the skew is more drastic for the women's team. And this is when that meme of stats being an art, an English, and whatever is kind of coming alive. You are going to have to write in this class. So try to write in complete sentences. I'm not an English teacher, so I won't be too crazy. But yeah. Okay. So for outliers, we said that women had 2 large outliers, meaning they're on the right or they're skewed right. 9 and 10 goals. Whenever we can put context, that's making our answer better. While men had none. Now, until we have an actual equation for outliers, maybe some of you thought 6 was an outlier, but for the men, but I really don't think so. I mean, it only skipped one value there. So women had 2 large outliers while men had none. Okay, so already we're seeing how different these distributions are. For center, you get to pick. Do you want mean, median, or mode? I'm probably going to pick mean, the average, since I don't know, I like the mean, and while the women's was skewed, the men's wasn't. So this feels like a fair way to compare them, but you could have also used the median, and that's totally fine. So again, comparative language. So women had a average goals scored, and that was 3.15, I believe. And I'm going to say that was higher. So again, we're looking for that comparative. Like, don't just state, oh, the mean of this was that and the mean of that was that. Which was higher? What does that suggest? Okay. What conclusions can we make? So women I was saying use complete sentences and I'm already not making sense. Women had on average goals scored of 3.15 goals, which was higher than the men's. And we have to find the men's, okay? So I actually already found it. That's how I knew the women's was higher, but I think it's pretty obvious the women's will be higher just based on their data alone. So to input the men's data, you're going to click stat, enter, and then you're going to arrow over to list 2, okay? Because we want the women's in list 1, the men's in list 2, okay? So I've already inputted the men's data in here because that would be very boring to watch me do that. So I'm going to do stat, arrow over to the right, 1 variable stats. Now this is for the men. This is for the boys team. Oh, what? Oops. I made a mistake. Sorry. 1 var stats. The men's is in list 2. So I've got to change it. second L2, okay? So second and 2 key to change it to be list 2, okay? So men's in list 2. All right, and we get an average of 2.05, and we get a standard deviation of 1.93, okay? So average 2.05, standard deviation 1.93. Do you think I can remember that? I don't think I can't. I'm an old lady. Okay, 2.05. Okay. Women had an average goals scored of 3. That doesn't sound quite nicely. Women had it's all right. Well, it's fine for now. Women had an average goal scored of 3.15 goals, which was higher than the men's 2.05 goals. Okay. And then last but not least, we've got the spread. So we talked about standard deviation up here, and I think that's more where we want to be than just giving a range. So again, the women, I'm going to use better English this time. Women were more spread out. Women's data was more spread out with a standard deviation, average deviation from the mean of, what was it? 2.58 goals, okay? So on average, differing 2.58 goals from the mean. Women's data was more spread out with a standard deviation of 2.5 goals, while the men's data had a standard deviation. Be careful how you shorten it. Standard deviation of, and I forgot what it is, grand finale here, 1.93. So the men's data is less spread out, and we can see that just by looking at it, right? The men's average was 2.05 goals, so that would be just right around here. And we can see the data is much more closer to that mean than the women's data, right? There's no outliers hanging out there. So that is how you would compare and contrast, describe both distributions. And again, I'm looking for comparative language. Who had a higher one? Who was more? Who was less? Who, men had none. So make sure you're comparing the two distributions, okay? Not just listing information. All righty. So that's all I have for you today. Email me with any questions.